Yes, hi everyone. Good morning. Yes. What we'll do is I'll quickly share the data on your drive, and we'll start working with this case study, right? So today is day 17, EDA and clinic case study, right? And here I'll just upload the two files required for. All right. Can you guys see on your drive? Can you guys download this? See, what is this is basically, this is one zip file which I have uploaded. Um, and in that zip file, what do you have is you have a data set that you need to download, and you have a case study Python notebook, right? What is there in that Python notebook? It's just a black box. Like uh, we have given a structure that we need to follow. Basically, stepwise assignment, right? So do that quickly. Just download that and be ready with this notebook. Then we'll start with the next part. Let me know if it is done. So as we have studied in the last session, the case study is nothing but it's a just a minute, just a minute. Give me a minute. It is nothing but it is nothing but the team at Google Play Store wants to develop a feature that would enable them to boost their visibility for most promising apps. Now, this analysis would require a preliminary understanding of the features that define a well-performing app. And you can ask questions like two questions. Does the size of or price necessarily mean that an app would perform better than other apps? Or does a higher number of installs give a clear picture of which app would have a better rating than others? Right? So for this visualization, we are going to revise some of the concepts that we have studied in Matplotlib, right? And you'll be introduced to the popular library called Seaborn, and which gives you access to a lot of flexible and aesthetic plotting methods. The Seaborn is another library that we are going to see over here. And third, we are going to at the end of the session, I'll introduce to you with the new library. You'll also get a brief exposure of Plotly, which is another visualization library that helps you make beautiful interactive charts in Python. right? That will be your agenda. Now, how to go through this particular assignment? You are encouraged to code along with me as I am going to explain each step, and this will help you out to get a strong grip of various tenets for analyzing datasets and to think like a data scientist in any scenario. Also, this notebook will help you with your reference to revise any concepts with specific to this module. The code stub has been provided to you, a black box. You can download and start working on that. All right. Now let us start with this. You can do simultaneously with me. If time does not permits, I'll just keep. I'm not going to provide a sufficient amount of time because this will be very uh, extensive session. It will require at least 2 hours to complete this. So if you want to do this, you can do this, but time we have a time constraint, so it is not uh, possible to give a sufficient amount of time to practice this, right? Now we have to solve these two questions, like as you have known, you have discussed. Does higher size and price prime necessarily mean that app would perform better than other apps, or does a higher number of installs give a clear picture of which app would have a better rating than others? So let us start with this. We have this data in which you have application name, category to which it belongs to, rating of that particular app, reviews given by customers, size of that app in bytes, installs of that particular app, type, whether it's paid or free, price, content rating, genres, last updated date, current version, and Android version. Right now, let us start exploring this. We have shape. Uh, we have already seen the shape of the data. That is 10,841 records. And we have 13 features. So very first thing that we need to do is we need to check the data type of each column out there, whether that data type justifies that particular column or not. So as I was discussing in the last session, um, some of the columns are not appropriate. You'll get an idea about that if I just check the data flow. Application name is object, so it's a string type of variable. It's a categorical variable, right? Category should be categorical. Rating is float, right? Reviews is something which is in numbers, right? Then why it is in object? It should not be in object. First point. So we have to validate this point. Why reviews in is in object? Why size is in float? Float is right. Is it correct? Yes. Installation. Installation also should be in numbers. So there is a sign, there is a little caveat over here, that is plus sign, that we need to remove so that it should be in numbers, numerical column. Type is object, fine. Price, it should be object, but why it is an object, we have to check that. Content rating, rating is in object, genres object, last updated object, current version object, that is fine. And Android version is object. But there are 2 or 3 columns that are in object that we need to take care of. So let's discuss this point. Like some of the columns that we have rating uh, have missing values, as we have discussed, right? 1474. And some have incorrect data type. So we can write down that. So I'll quickly write down the data set uh, rating have missing values and some have incorrect data types, right? Associated with them. So let us discuss both of them. First, we'll do is missing values. You would almost always encounter data which have rows where no observation is recorded for certain values, a variable. This can affect analysis process, and the generated insights significantly uh, can be affected. So some of the common techniques to treat these issues are, as we have already discussed, what should we do? We should impute that. So imputation. And second is dropping the rows containing the missing values. Imputation is where you place the missing value with another estimated value. Or depending upon the case, you can also go ahead and keep missing values as long as they don't affect the analysis. Second type of issue that we have is incorrect data types. The discrepancy mostly occurs due to some incorrect data or entry in the column, which is stored in a format other than the desired one, due to which the entire column gets misclassified. Or in some other cases, the format of the entire column is different from what we need for our analysis. So you have to fix them to certain values and clean the entire column only to bring the correct format. Missing values will affect our statistics drastically. For starters, our inbuilt functions, mean, sum, variance, etc., will give incorrect results. So, which clearly is quite dangerous, right? And also, you need to have the values to be in numerical format of integer and float to perform these operations. You cannot find mean, median, mode of collection on strings, that is object column. That is second problem. So now you have, before you proceed further with the data analysis or visualization part, it is essential for you to remove the above discrepancies that we have discussed. So let us start working on that. We have calculated missing values, handling missing values for rating. How do we do that? For rating, ratings is the target variable, and we need to drop the records over here. So let us add this, drop the rows having null values in the rating field. So I'll write an input 1. In that input 0, negation, the sign that we already have used, input 0, rating column dot is null, not equals to is null, right? So this will contain only the rating column which does not have a null value because we are using this sign, right? And we need to check the shape of the data set. So this sign is your inverting sign. It inverts the result. inverting the result. So exactly opposite values for that particular column. So input one dot shape, if you do, now it is 9367. Earlier we had 10,841. So we have removed this 1474 values in our rating column, right? Now check the number of null values again in the rating field again to cross verify. So input one dot rating dot is null dot sum, open and close bracket. So we don't have null values in our rating column, right? And for all the columns out there, check the number of nulls in the data frame again and find the total number of null values. So what you'll do is you'll write down input one dot is null dot sum, open close bracket, right? And you're going to inspect the nulls in the Android version column. So input one of Android version column dot is null, open close bracket, this. So for Android version, we are inspecting the nulls in that. So these are the three null values in the Android version column, right? Only three, because here we have three null values. So what we can do is we can drop the rows having uh, shifted values. If you see what I was telling at the front itself is reviews column should be number, right? So this row 10,472 row is mismatched, I can say. Category value you don't have. Rating value was 1.9, so it is over here. Reviews is 19.0, it is over here. Size is 3.0, so it is left to this. Installation is this. Type is free here. Price is 0 here. Content rating everyone. Genres none. Last updated is this. Current version is this. And Android version is this. So it is kind of shifted. Are you agree with me? Yes, everyone. It is shifted row or not? Can I get response?
Yes.
Yeah, you can unmute and speak, guys. Now it's time to discuss.
Yes, Gopi.
Yes, so what we'll do is for 10,472 record, for all the columns, I'm taking this input input one of Android version column. You can copy the name of that column. If it is null, and and input one dot category is equals to 1.9. So I'm just extracting this particular row, right? Wherever the Android version column is null and wherever the category is 1.9, I'm just extracting that particular value, right? And I'm going to check the nulls again in Android version column to cross verify input one of Android version dot is null, open close bracket. Input one. This should be input one, right? What is happening is one more thing is remaining is We need to neglect that, right? So this thing is fine. This thing is fine, but we'll save that in input one data frame. And I don't want, so I'll invert that. I don't want this row, right? I don't want this row. So I'll just invert this by using over here. So I will have only two rows. If I just restart and run all this, I'll be having only two rows.
Yeah, the variable is different. I think the name, that's why it's showing the 1.9, the sixth line starting.
Uh,
Oh,
Here, right. So we only have two, right? We have removed this by using negation. Now it's time to impute missing values. It's time to impute missing values. So for numerical variables, we use mean and median. And for categorical variables, we use mode, right? So now checking the most common value in the Android version column. So I'll write on input one of Android version dot value underscore counts, open and close bracket. I have this most common value because I want to impute that with mode value. This is my, is it categorical or numerical? Android version, it is categorical. So we have to remove that with mode. 4.1 and up is the most occurring value for that particular column. So I'll put heading as fill up the nulls in the Android version column with the above value. Input one should be exactly equals to Android version is equals to input one of Android version dot fill na of input one of Android version dot mode. And I'll replace this with um, yeah. If you write on mode of 0 means first value, right? Mode of 0 means this first value, this one. So if I just uh, write down this here, that will give me the first record mode, and if I use this, will give me the mode. I'm specifying the only zeroth record over there, that is 4.1 and up. You can do that fill in a with uh, is equals to sign and 4.1 and up. That is also possible. Like you can write down this Android version is equals to in quotes 4.1 and up. That is also possible, but I'm doing this thing. Now I have f- fill that particular record with the mode value, and I'm going to check the nulls in the entire data frame again. So I'll write an input one dot is null dot sum, and I'm going to get this record. So for Android version now, earlier we had three null values, if you have observed that. Now how many null values do we have right now? Zero. So by imputing with mode, right? Now similarly, we can do this for current version. Same thing for current version column. So check the most occurring values in the current version column. Current version column. Here it should be current version. Value count is varies with device. First is varies with device. So we'll remove by using the same principal. So I'll just copy this. I'll paste it over here. I'll write down current version over here with the above value. Here it should be current version. Here it should be current version. And here it should be current version. Done. It is filled. Now we'll solve this question. Check the most common values with. No, I think it is done. Um, yeah. So now if you just check input one dot is null dot sum, we have zero null values for all the columns. Yes or no? So we have treated the null values significantly. Is it clear now?
Yes, sir.
Oh, perfect. Now we'll handle the incorrect data types. In that, we are going to write down check the data types of all the columns. We'll write down input one dot d types. I have this much data types in my data, and we have discussed that size should be, sorry, review should be object, right? The review should not be object, it should be numbers. And this price should be number, right? So we'll deal with that. So the question now is, we need to try calculating the average price of all apps having the Android version as 4.1 and up. We'll let an input one dot head. Try calculating the average price of all the apps having Android version as 4.1 and up. And we are going to analyze the price column to check the issue. So we'll write an input one dot price column value underscore counts. So what we'll do is we are interested to convert this price column into what? Float. So because of this dollar sign, it is treated as the object column, right? So we'll write a lambda function. Now this is very helpful. This is going to be very helpful for you in your entire machine learning journey. So listen this very properly. As I told, lambda function will be your savior for the life, right? You should be expert in this no matter what. There is no any option. You have to learn lambda function. You have to learn applying lambda function wherever it is possible. So for all the x, I'm passing 0 if x is exactly equals to 0. Means this column. This 0 is also not treated as object number because of this, right? We have dollar sign, so it has converted entire data into object. So lambda passed treat x is equals to 0 if that particular x is 0 in quotes, means object 0. Otherwise float of x of 1 to all the values. 1 to all the values. Now this is x of 0, this is x of 0. And from this data to last, it should be x of, just a minute, it should be x of 1 to last. So float, I mean, if x is equals to 0, if x equals to this code 0, this is code 0 because this is object column, replace that with 0, else float for all the x which belongs to 1 to last. So 1 to last means the remaining column that will be converted into float. And let us see if it is converting or not. Yes. And now you can verify the data type of price once again by writing down input one dot price dot d type. It is float 64. Done. Now you can analyze the reviews column. Input one dot reviews dot value underscore counts, close bracket. This is integer. Reviews is integer, right? So it is integer 64. If you want, you can convert that into integer 32. That it's not needed. But let's say you want to change, you want to see how do we change the data type. Of this column. So we'll write an input one dot reviews is equals to input one dot reviews dot es type integer 32. And you have to check the quantitative spread of this data frame. We'll write an input one dot reviews dot describe open close bracket. And now if you just check value counts for the review column, it is converted to integer 32, right? And then after this, we are analyzing the installs column, because install column is also having which data type? Installs. It should be object. It should not be object, right? It should be your uh, numerical column installs. So because of this plus, it is converted into your object column. We'll write down input one dot installs dot head. This is your installation column, and you are going to clean the installs column and find the approximate number of applications at the 50th percentile. So we'll define clean underscore installs. This is your function that you're going to pass value. It can be anything, VL, AL, anything. I'm going to return the integer value dot replace. I'm going to replace wherever it is there is a comma. Wherever there is a comma, here, I'm going to replace that with space, a blank space. I don't want this 10,000 Indian format, so you can do that. Plus, I want to replace wherever there is a plus sign. Wherever there is a plus sign, I want to replace that with again a space. And then you can check type of clean underscore installs, the calling the data frame. In that, let's say you pass this 10,000 plus, just in order to ensure if it is running properly or not, right? So you can take this, can paste it over here. So what is type of this clean installs? Even though it has plus sign, even though it has comma, is it converted into integer? Yes or no, guys?
Yes, sir.
Yes, it will.
It's a string, right? But by passing this with clean installs, it is converted into integer because of this integer and then replace, right? So that is also very helpful for you. This function is very helpful. Then for installation column, I'm going to use install, and I'm going to apply my clean underscore installs function that I have created earlier for all the install column, all the values in installs column. And then I can check install.describe. Installs. S should be there. S. And you have this float value 64 data type. It's ready. See, earlier it was in object, so you cannot find mean median mode. Yes or no? So this itself tells us, without seeing this data type, itself tells us we are getting count, mean, standard deviation, means that is your numerical value. Can we have mean median mode for uh, object column? Can we have that?
No.
Right, we cannot have. So that is what we have for this. I'll hold for 1 or 2 more minutes. Let us take a break over here for 5 to 7 minutes. You go through this. If you have any questions, you can ask over here, right? Otherwise, what we can do is best part. Let us shift to Collab, and I'll share the Collab notebook link so that it would be a live part for you. You can directly go to that particular link of Collab and have a look at this. Here you cannot have, right? So I'll just download this quickly, and I'm going to upload that uh, data set, Google Play Store CSV, over here, right? And I can directly open this notebook of this one. Perfect. Right. And here we'll require data, so we can upload it. And whenever we'll be having a break, you can come here and directly um, have a look at that. So there will be a live connection between my notebook and your system. So you can go through this. I think PD is not defined. You need to restart and run all this. And I should share uh, uh, drive link. Sorry, this notebook link. Let us rename this notebook as, it's already there, okay? Google Play Store case study. Let us change permission to anyone with the link can view. Just copy this. And this is your link, right? So let us have a break now. Let us have a break. But in this break, you just go through this notebook. Whatever we have discussed, you have to revise that. Is it clear, guys? So don't waste your time. Whatever we have discussed, just get familiar with that lambda functions and everything that till now. It's 9:50. Let's have a break till 9:56. All right. So let us go to next part. Now we need to go for sanity checks. So what do you mean by sanity checks is the data that we have, it needs to make sense, and therefore you can perform certain sanity checks on them to ensure they are factually correct as well. So some sanity checks can be rating should be it should be in between 1 and 5, right? The maximum is 5 and minimum is 0 should not be there. It should be between 1 and 5. First point. Number of reviews is less than or equals to the number of installs. That makes sense, right? If you have a number of reviews, it should be greater than number of installs. So there will be some malpractice in that number of reviews column, right? And you have free applications, free apps that should not have a price greater than 0. Should not have a price greater than 0. So let us perform the sanity checks on the reviews column. So input 1 dot reviews, it should be greater than input 1 dot installs, and you are just checking shape of that. Wherever input 1, just a minute, not supported instance and input and string. Let us try doing this in the here. Of integer and string, but we have converted installs in uh, the float column, right? Or is it install? Installs. It should be installs. That's why it is not happening, right? It should be installs because in that data frame, install should be the column. So I'll just restart and run all this and then perform the sanity checks. Because of that ace is missing, it is created new column, I think. Now it will work, right? So we have 7 rows and 13 columns, which exactly follows this uh, condition, wherever reviews are greater than installation. And if you want to have a look at that, you'll just write down this part, this. So wherever input of reviews are greater than install, these are the uh, records. So 4 reviews, but only 1 install. So it means that one user has given 4 reviews, right? 10,000 install, but 10,249. One install, 2 reviews. So there is some fishy over here that we need to take care. So input 1 of input 1 dot reviews should be less than or equals to input 1 dot install, because we should our data should follow that condition, right? Now we need to perform the sanity checks on prices of free apps column, input one dot type equals to free, and input one dot price greater than 0, price greater than 0. So perform sanity checks on free apps. Do we have this kind of condition? We don't have. We don't have this. Wherever price is greater than 0 and type is free, it should not be there, right? Price should be exactly equals to 0, then it is called as free app, right? So that is what we have. Uh, so then outlier analysis we are going to do using box plot. Yesterday only we have discussed. Now you need to start identifying and remove extreme values or outliers from our dataset. These values can tilt our analysis. So I'll quickly take out that theoretical part. Just give me a minute, and then we'll uh, discuss this. So wherever there is a outlier, it leads to a biased perspective of the data available, right? And we need to take care of that. So how will you do that? By using box plot. So let me take that explanation for you. I'm not going to write it down. It's very simple. We already have discussed what needs to be done. Just a minute, guys. Um, Outliers analysis using box plot. Right. Perfect. So I'll just take this. I'm going to paste it over here. Um, and you can read this. Now you need to start identifying and removing extreme values or outliers from our dataset. These values can tilt our analysis and often provide us with a biased perspective of the data available. And this is where you'll start utilizing visualization to achieve your task. Everything we have discussed in our official, in the last session itself, right? So this is just a theoretical part. Already we have completed this discussion. So what I'm going to do is I'm going to provide the official documentation link, which you can follow for your reference of box plot. But anyway, you guys are confident in that. You know how to plot the box plot, right? So let us start working on that now. So for that reason, we are going to import the plotting libraries. Import matplotlib.pyplot as plt. And you are going to write down percentage matplotlib inline this one. And what is this inline? I'll just give you an idea about that. What is this inline? It will just make sure that your graphs are inline. The graphs that you're going to plot for uh, by using matplotlib will be in line with the output. It will not be outside of that output. That is what it is. Specifically within Jupyter Notebook environment, the magic command is used to configure matplotlib to display plots directly within the notebook itself, rather than separate windows. So that is your command. Simple. So you need to write down that, right? Now we are going to create a box plot for the price column. We'll add on plt.boxplot, input one dot price, and plt dot show. That is what it is. And now we are going to check the apps with price more than 200. Input one dot price greater than 200. This. So check the applications of price more than 200 because that is your expensive app. So price greater than $200 are this. So what we are doing is for the price column, as you know, in this box plot, this center line is your median, right? Q2, that is your median. So we are just finding that particular value of Q3, 75% of the data, or Q1. And if the value is greater than this thing, the upper whisker region, we are going to check that. So for your price column, you write a describe function, and you can get an idea about the value, a particular value. Describe. So maximum is 400, median is 0. How it is possible? Okay. So yeah, so most of the data points are lying on why it is called as outliers are over here. In our case, it's just like you're doing analysis, salary analysis of the employees, and you have taken most of the records for director level people. Just like that. Directors, CEOs, CTOs. So obviously you will be having outliers in your data. So you're doing analysis of free applications. You want to do analysis of free applications, free apps, but most of the data points are paid. They're having more than $200. Most of the data points are here, are having more than $50. So that is known as outliers. So we are going to put a condition wherever the price is greater than 200, we are just checking that. And what we'll now do is we are only going to select the, because hardly if you just check the shape of this data, wherever the price is greater than 200, if you just check shape of this record, shape is not callable, I think. So we should not give that. Only 15 records are there, 15. So we can neglect that, right? We can skip that. So clean the price column. Input one of input one dot price should be less than 200. Only selecting the records which has less than 200 price, right? And we are going to use the describe function. So maximum now it is 79. It looks good. And again, if you just try to plot a box plot by the same lines of code that we have done earlier, this is also you can follow, or I'll tell you second method to plot the box plot. Chalo. Second method for box plot. Input one of input one dot price. It should be greater than 0, filtering the records. And for that records, I'm going to plot the box plot. So input one. So selecting only those record where price is greater than 0. Now what we'll do is, again, we'll put a condition checking the applications with price, because here if price is greater than 30, we can still filter the record out because that is ultimately there are outliers. If the price is greater than $30, that are my outliers. I'm confirmed with this statement, right? This sure shot. If the price is greater than 30, They are my outliers. So I'm just selecting input one dot price. It should be greater than 30. I'm just taking that particular records. And if you just check shape, we have only 6 columns, 6 records. So you can clean the price column. Let us clean the price column again. And input one is equals to input one. So that's how you find a validation to the data, right? Selecting only those record where price is less than or equals to 30. So we have converged our price column from 400 or $200 to $30, right? So that is what it is. Now it's time to go for histogram, applying your knowledge of histogram, which we have done in the last session. Histogram. An histogram can also be used in conjunction with box plots for data cleaning and data handling process. You can use it to check the spread of numerical values. You can use it to check the spread of your numerical values. So I'm going to create a histogram of the reviews column. If I want help of plt.hist, I can write down this. It will give me the help, like what should be done, what are the parameters that you can add. So this is your help. Then I'm going to plot histogram for reviews column. So this is your histogram for reviews column, right? And if you see, most of the reviews are in between 0 and 1. 10 to the power 7. So again, creating a box plot of the reviews column, plt dot box plot for input one dot reviews and plt dot show, open and close bracket. And now I'm going to check the records with 1 million reviews over here. The input one of input one dot reviews, if it is greater than or equals to 1 million. 1, 2, 3, 4, 5, 6, 7. 7, yes. Checking the records with more than 1 million. So we have 92 records, which has more than 1 million reviews. So what we'll do now is we'll drop the above records. Input one is equals to input one dot reviews, selecting only those record less than 1 million reviews. So 1, 2, 3, 4, 5, 6, 7. And then you are going to check the shape of the record. So filtering the records where reviews are less than 1 million. Now we are left with only 9. Oh, it should be 8,000 somewhere around. No, it should be 8,000. So 1, 2, 3, 4, 5, 6, 7. I think it should be 6 only, no? Let me check. Six, right? Six records, six zeros in 1 million, not seven. One, two, three, four, five, six, seven. Okay. So less than, dropping the records with less than um, um, or only selecting the records which has more than less than 10,000 10 million views, not 10 million, 1 million views, right? So we have left with 8634 now. This is good. Now question is, we need to create a histogram again and check the peaks. Now you'll get to see that if you write on pld.hist, the same function that we have used for histogram in earlier part for reviews, you can take that and paste it over here. By pld.hist input one.reviews, pld.show. This is your part. So earlier it was very high as compared to, means you are not having records over here. We have minimized that. If you see the frequencies, earlier it was 8,000. Now it is somewhere down 7,000, right? And there's a significant amount of votes or records for this record as well. So that was not clearly uh, visible because of the high amount of reviews, because of the rows which has more than 1 million reviews. So we have filtered that out, right? And anyway, if the application has more than 1 million reviews, it obviously performing well. We do not have to consider that particular application, right? There's no any point of improving that particular application or just checking that or having analysis of that because it is performing very well. We are interested to perform a check the analysis for that particular applications which has less, which is not uh, that famous, right? So for reviews box plot, we can get an idea about this by using statistical analysis, describe, open and close bracket, input one should be there, right? Describe series object don't have describe spelling. All right. Now question is, you need to clean the installs by removing all the applications having more than or equals to 100 million installs. More than or equals to 100 million installs. Input one, only selecting that particular columns, where that particular records where install is less than or equals to 100 million will have 8, I think, no. 100 million, 8 zeros, right? Let us confirm this. 1, 2, 3, 4, 5. Let us copy this. Best way is to copy that and paste it over here, right? And input one dot shape. So we have 8624 now. Now plotting the histogram for size as well. Input one dot size. Size column has S capital dot plot dot hist. So likewise also you can plot this together. This is good. We can have a descriptive statistics of this column as well. Size dot describe. Sorry, size dot describe, and we can create a box plot for this, for the size column, and report back the median value. So pld dot box plot input one dot size and pld dot show, open and close bracket. So that is what we have. Now we'll quickly proceed further with session 2, that is data visualization with Seaborn. And what is Seaborn? Seaborn is a Python library. It's a Python library to create statistical graphs easily. And as I discussed earlier, it is built on top of matplotlib and closely integrated with pandas. The functions of Seaborn are functionalities of Seaborn are dataset oriented, API, analysis, analyzing univariate means only one variable at a time, and bivariate means two variables or multivariable. Bi means two variable, means you're analyzing two columns at a single time, or you're if you're analyzing only one column at a one time, then that is a univariate. Simple. And plotting of linear regression models. And there's convenient views for complex data sets. And we have concise, CONCISE, concise views for complex data sets. And concise control over style. And color palettes are also very excellent. So these are the advantages or functionalities that this particular library offers. So we are going to import the necessary libraries. We're going to import warnings, warnings dot filter warnings, in quotes ignore. What is this? It's very useful function. I'll just comment this out, and I'll explain the importance of that. Right? We get warnings by using Seaborn. That is generally can be avoided by using that. Right? So let me uh, take a theoretical part of dist plot, distribution plot. It's same like your histogram, but you get a distribution of the data out there. For an example, what I'm trying to say is, suppose you want histogram as well as a distribution of the data. Suppose you have plotted a data with the histogram like this. And how do you get a distribution? You join the edges of the histogram. You join the edges of the histogram, right? You will join the edges of the histogram. Connecting the edges of the histogram will give you distribution plot. So if you just erase your histogram, let's say I'll erase the histogram, that will be your distribution, right? So if you're wondering how we get a distribution plot like this, you might have seen this, right? This type of graph. How do you do this? We have a histogram and we just plot the connect the edges of the histogram so that we get a graph like this. That is known as distribution plot, right? And if you just remove the histogram, you'll be left with the distribution like this. Is that making sense? So let us see how do we plot the histogram. Now we will create a distribution plot for rating sns dot displot input one dot rating and plt dot show open and close bracket. So that is your distribution plot for rating, right? And what is this? As I told, it gives warning. Please adapt your code using this plot, like dash dash dash. This is a warning. I don't want this warning, user warning. So I'll just make use of filter warning library. And now I'm trying to run this. You'll surprised to see that we don't get warning now. We just run this. Can you see this? We are not getting warning. So that's why it is used to filter out the warnings, right? Now I want to change the number of beans. Here, how many beans do we have? You can calculate 1, 2, 3, 4, 5, 6, 7. Multiple beans are there. If I just want to restrict my beans to 20, so I'll write down sns.displot for input rating column. And I'll introduce one parameter, beans is equals to 20. So that is how it is. 20 beans will be there, right? Now, if you want to change color, how will you do that? I want to change color. How you can do that? You can copy this. Same thing. Change the color of beans to green. So simple. You'll add one parameter called as color is equals to, you can write on green or you can write on G for green. G for green. Right? Now you want to give title. Title you can give by using matplotlib. Cbond does not carry the provision to give title. So apply matplotlib functionalities sns.displot plt.show we'll write on plt.title distribution of app ratings, and you'll write on font size is equals to 12. Simple. And now you'll be having styling options. One of the biggest advantages of using Cbond is that you can retain its aesthetic properties and also the matplotlib functionalities to perform additional customization. Before we continue with our case study analysis, let us study some styling options that are available in Seaborn. Let us study some styling options. So you can go to official documentation and check the styling options. I'll just share a link for that, and I'm going to uh, jot down some of the important styling options, right? So you can check all the styling options by using question mark sns dot set underscore style, and you're going to write down set underscore style, and you're going to write down sns dot set style as dark, and you're going to write down sns dot dist plot input 1 dot rating comma bins is equals to 20 comma color is equals to green. You write down plt dot title. Title is distribution of app ratings, comma, font size is equals to 12. plt dot show, right? So just so what I'm doing is question mark is sorry. I've written the same thing, right? I want to set a style, so check all the styling options. That this is what happens if you are continuously doing coding, right? SNS dot set underscore style will give you an idea about the just a minute, guys. Just what I'm doing. Yeah, this is how you set a style, right? By you're doing dark, so background is dark. Disk plot is for is input dot rating. Beans is equals to 20. Color is green. Title is distribution of app ratings. Font size is 12 and show. So that is your style number one. If you want, if you don't want dark background, you can write down. You can set style as white background. So that is also possible. WITE, white background, right? And if you're just interested to check what are the different styles available, so you'll write on plt.style.available, and you'll get everything. So we have solarized light, classic test patch, and these are the styles available. You can make use of that by using plt.style. Suppose now this is matplotlib style, right? This is not your Seaborn style. So I want to get Tableau color blind 10. Tableau color blind 10. I'll just select that. And then I'll start uh, writing down the code in matplotlib, changing the number of bins to 20. So we'll write an ss.dispplot input 1 dot rating comma bins is equals to 20. And you'll write an plt.show, open and close bracket. Now you're going to write on plt.style. You're going to use ggplot. The style is ggplot, nothing different. And you can plot this plot of input dot rating comma pins is equals to 20, and plt dot show will get the ggplot. The style ggplot is this. This is your style. Or you can use dark background style. Can copy this. Instead of this, you can write on dark underscore background, and you'll select the this part. This is your dark background, right? And let us set style back to default by using this percentage matplotlib inline. And you'll write an ls.displot input one dot rating over beans is equals to 20 plt dot show. That's what it is. So this is for your styling purpose. Now we'll quickly see what is pie chart. How do you plot pie chart? How do you plot um, bar chart? We'll see that. So I'll just add this, add it here. So I'm going to write down analyze the content rating column input one dot content rating dot value underscore counts close bracket, analyzing the content rating, and I'm going to remove the rows with values which are less represented, So less represented are adult only 18 plus and unrated uh, content rating. So removing that will be, you can use this thing which is suggested by Google Colab, or you can write on negation of input one of content rating. As we have discussed in the previous session, we have ease in method, right? Which simply helps you out to select multiple columns. So I don't want adult only 18 plus because that has only 3 records, and I can remove unrated that carries only 1 record. So does not make any sense to have it in our data. And now if you just check input one dot shape, so that is your 8620, 13, right? Now index in our uh, data frame, we have index as we don't have index, but if I want to reset the index, we have seen this in very basic session. Input one dot reset underscore index. I want to in place this with true, comma drop is equals to true. So in place is equals to true means I don't want index. I'm resetting that and dropping that. And if I check input one dot info, this is what it is. Now, for content rating, we are again going to check the value counts. Check the apps belonging to different categories of content rating. Input one content rating dot value counts. So we only have 4 column, which is looking good. Now it's time to plot a pie chart. So how do you do that? You'll write on input one for which column, for content rating column. What do you want to do? You want to, for value counts, you want to what? Do what? Plot dot pie. If you do this, you'll get this. And if you don't want this, so you'll write down plt dot show. Simple. So this is your pie chart by simple pie chart by using matplotlib. You can do some modifications in that by using cborn, but that is depending upon user, right? I don't need to worry about that. You can do explore that, uh, but we'll not take care of that because what is important for us is to just have an understanding of how we plot the pie chart, right? Beautification, cosmetic work, you can learn it by your own. Now you have to plot the bar chart for this. Input one, content rating column, dot value underscore counts. We'll write down dot plot dot bar. So it was back. Write up value dot show. I think the input one should be there. It is showing the error over there. Input one. So this is your bar chart, right? And you want horizontal bar chart, like it should be tilted with the 90-degree horizontal bar chart. You can make that possible by using this. You want to plot the bar chart for checking the fourth highest Android version type. So we'll write on bar H for that, right? Bar H will give you horizontal bar graph. Is it fine now, everyone? Do you have any questions in this? Till now, whatever we have discussed, do you guys have any doubts, any questions? I can see only two responses. What about other guys? Can you please respond yes or no with yes or no?
Yes, people.
See, this is nothing special. We are just making use of our coding knowledge, whatever we have discussed till now. That's all. Now, see, what is scatter plot? Earlier also we have discussed. It is one of the most commonly used, well, one of the most powerful visualization you can use in the field of machine learning. They're pretty crucial in revealing relationship between the data points. You can generally deduce some sort of trends with the data with the help of scatter plot. Description, we already have discussed this. They are useful in regression problems to check whether a linear trend exists in the data or not. For example, image below creating a linear chart in the first case makes far more sense since a clear straight line trend is visible. Now, if you just remember, I have given on your drive, I have given you guys will get to see the images, right? Images for different charts. So in that, if you see scatter plot, you'll get to see an image, or you can take that, you can paste it over here. Where? Here. So what I'm doing is I'm pasting that particular image over here. This is what the image is, right? And they'll help you in observing naturally occurring clusters. In the following image, the marks of student in maths and biology has been plotted, and you can clearly group the students to four clusters now. Cluster 1 are students who score very well in biology but very poorly in math. Cluster 2 are students who score equally well in both the subjects and so on. And this is what we are. So we'll be studying both regression and clustering in greater detail in machine learning modules. Uh, Whenever we are going to start machine learning. But at this point of time, you should only know how do we plot the scatter plot and how do we plot the joint plot. So let us start working with size versus rating scatter plot. So I am interested to plot a scatter plot in the matplotlib way between size and rating. So I'll write on pld dot scatter input one dot size comma input one dot rating, and I'll write on pld dot show open and close bracket, and I'm going to write down plot the same thing now using a joint plot. This is dot set underscore style. I'm setting this as white. So this is a scatter plot for x-axis we have size, y-axis we have rating. You can give title, which we have seen in the last session. Now let us go ahead with the joint plot. So what is joint plot? I want to have an joint plot. I need to have a help for this. So it provides convenient interface to the joint grid with several canned plot kinds. This is intended to be a fairly lightweight wrapper. If you need more flexibility, you should use joint grid, and these are the parameters that you can pass. So you need to write on sls.joint plot between same two columns, input dot size, input one dot rating, and you can write on pld dot show. Okay, what it is saying is it requires 0 to 1 position to 1. How this is possible? You should have to know. If you just run this, it says these are the parameters you can pass, data and x. So it can have two. Okay, let me take this in uh, your here. PLT is not defined. You have to import matplotlib here. And this. Can you see we are getting here, but we are not getting here? I think we should pass x is equals to this and y is equals to this. Now we are getting this. So this is your joint plot. What is joint plot is? It gives you scatter plot as well as histogram. Scatter plot as well as histogram. So this line belongs to this belongs to this particular line belongs to this. Similarly, this particular line belongs to this, right? So that is a scatter plot plus joint plot. Now you can do for other columns as well. You can plot scatter plot for other columns as well. Plot a joint plot for price and rating column. So here it should be price, PRIC. And now you're going to have regression plots. These are an extension to the joint plots where a regression line is added to the view. These are an extension to the joint plot where a regression line is added to the view. Now I'm going to plot a regression plot for price and rating and observe the trend. Analysis.join plot input one dot price comma input one dot rating comma kind is equals to regression reg, and I'm going to run pld.show. Again, join plot should be specified x equals to y equals to what. So there will be a regression plot. Kind is equals to reg. You will get to see everything in the official documentation of the joint plot. So it's you do not need to have an understanding of all the parameters out there. You can go and explore this, and you can see in data you can add this. In kind you can add KD, histogram, hexagonal, regression, and other parameters as well, palette, right? So you do not need to have an understanding of uh, everything. So this is your regression line. Can you see this here? This is your regression line for the two data. Now, what is regression? You are going to see it in machine learning. So just like you plot your data on X and Y axis, data will be like this. You try to fit a line which will cover all the data points and try to predict the uh, future data point. It's a predictive analytics. In more detailed fashion, we are going to see this in our machine learning part. So that's what your joint plot is. Now you are going to plot a regression plot for price and rating. And again, for only the paid apps. So for paid apps only. So uh, you are doing joint plot for price column. P is capital for price, comma, rating column, R is capital for rating, comma, data is equals to of input 1 dot price greater than 0, comma, kind is equals to regression, plt.show. So argument got multiple values. Okay. X is equals to this, Y is equals to this, data is equals to this. So wherever the price, we are only interested to find the regression plot for paid application where price is greater than 0. Simple. So that's what it is for your joint plot. Now we'll see, we are going to see the next type of plot, that is pair plot. And what the pair plot is, it gives you the scatter plot for multiple columns. So this is your multivariate analysis. This is your multivariate analysis. What is multivariate analysis? You are going to have discussion on multiple variables. You are going to analyze multiple variables at a time. So that is your pair plot for you. So you will create a pair plot for reviews, size, price, and rating. So question mark SNS dot pair plot is this. So you'll get help of this, or you can go to the official documentation as I discussed how to go that, how to check is SNS dot pair plot. And go to official documentation to check the different parameters that you can pass inside this. Now, I need to have a pair plot for multiple columns. Like, how do we select multiple columns? By making use of double square brackets, right? So I'll write down reviews, size, price, and rating. And if you do this, it generally takes time to plot the pair plot because it has a scatter plot for all the columns out there. And how do you read this pair plot? Is simply, just a minute. It is it is little heavy function. So if you have, let's say, 20 columns and you're trying to plot pair plot for that 20 columns, it will take multiple time. It will take 5 to 10 minutes. So how do you read this is, uh, here you have reviews, and for this column, let us scroll down. It is size. So if you want to have a scatter plot between reviews and size, so it will be a scatter plot, right? If you want to plot a scatter plot for reviews and, let's say, price, so this is your scatter plot for reviews and price. And for the same two functions, same two parameters, not function. Suppose reviews versus reviews, it will be here, right? Reviews versus reviews. For the two same, that is your diagonal element, it gives you the histogram. For diagonal element, it gives you the histogram. So here it is a histogram. For diagonal element here, you have histogram. Here, you have histogram. And here, you have histogram. Does that make sense? So that is how you read this. Now bar charts revised. Let us have a revision of bar chart. Now, let us revise bar chart. So you suppose, I'll just put multiple questions. How do we solve by using uh, bar chart? We'll just see that. We'll just see this function, this questions. How do we solve it by using your bar chart? So first question is, you need to plot a bar plot of content rating versus average rating. Input one dot group by content rating and rating column dot mean dot plot dot bar group by, this must be having six. Okay, this should be close with this, and no, sorry, repeat there. So between content rating and rating column, you're for rating mean, you are plotting bar graph. So this is rating mean. This is mean of the rating column out there. All right. Okay, so next question is you need to plot the bar plot again with median rating. Median rating. So input one dot group by of content rating. Here you will be having median instead of mean. You will be having median, right? And same will be there. So if you run this, if you see this, you'll be having a median. Now, SNS dot bar plot, we'll see bar plot. Data is equals to input one. X-axis, I want content rating. Y-axis, I want rating column. And I'm going to write down plt dot show, open and close bracket. So I'm going to get bar plot for content rating, right? And you can add colors to this by using style. If you just write down SNS dot set style. Earlier we have set style as white, is it? Hmm. Let us say dark green. And you can add colors to this by using color palette, color underscore palette is equals to color palette is equals to, let's say, color blind. Let's take this color blind. So how do you select that? You need to write out sls dot color underscore palette is equals to this one. Let us copy this. Let us add a new column. Let us paste it over here. And here let us select color blind. Color blind. Yeah, this one. So this and this. What is this? Color palette is equals to color line. But you don't have a attribute called color. Okay. Color is equals to. Still we have. Okay. You can select, suppose, see, for bar plot, I want to add colors using SNS. There's one parameter that you need to add inside that. Palette is equals to this. Okay, the parameter is palette. So I'll just take this out and I'll add it over here. Can you see this? Now we have color. So instead of this, I can add color blind. Right? This is how you can color the parameters. Now, this is all about your simple bar plot. Now, if you want to have a bar plot with the estimator value, plotting the above bar plot using the estimator parameter, bar plot estimator is equals to, let us have this. Let us add one more parameter, that is estimator is equals to np.median. That will give you median value, not mean value, or not any other parameter. I want to have median value, right? Or let's say I want to have minimum bar plot for the minimum parameter. So I can write on np.mean for that. Now I'm going to plot a box plot of rating versus content rating plt.figure. Figure size is equals to 9,7. SNS dot box plot input 1 of content rating, comma input 1 dot rating plt dot show. X-axis is okay. Here we need to always mention X and Y. In Jupyter Notebook, we don't need to mention that. Right. So this is a box plot for content rating and input rating. So everyone teen, everyone 10, mature 10, 17 plus. So that is what we have, right? Now it's time to study heat map and line plot. So we already have discussed stack bar chart. We'll discuss that stack bar chart. Yeah. Okay. Only few points are remaining. Before that, let us have a break for 5 minutes and then we'll start with the next part, right? All right, guys, let us do or let us study heat maps. Heat map is another useful visualization tool that will help you out whenever we are going to learn machine learning. So I would like to introduce that particular point at the time of machine learning. So we will discuss that more extensively over there. But I'll just show you how do we plot the heat map. That's all. And the reason behind plotting heat map, why generally we plot heat map, that will be taken care at the time of machine learning part, right? So let us not waste our time in discussing what is heat map and why it is used, right? So it is a concept of using colors and color intensities to visualize range of values. You must have seen heat maps in cricket or football broadcast on televisions to denote players' areas of strength and weaknesses. In the last session itself, yesterday, I have told you, we have discussed that beautiful example of cricket players and their runs and strike rate, right? That was another example that you can consider. It is used to get an idea about the uh, correlation between multiple features, right? So if you just write on heat map, this is how it will look like. It is just like color coding heat map. It's a correlation between multiple variables. When I say variable, means multiple columns, right? The darker is the color, the higher is the lower is the correlation, as you can see over here, scale. And higher the color, I mean the not higher, the the less intensity the color has, the correlation will be stronger. As you can see over here, right? If the color is darker, correlation is 20% only. But if color is faint, let's say here, so it is 80. And these are the values. So this is what it is used for. Now, um, what we will do is we will um, try to plot ratings versus size versus content rating. We'll prepare a bucket for this, the size column, using pd dot q cut. Right, so I'm going to write an input one of size underscore bucket is equals to pd dot q cut input one dot size comma 0 comma 0.2 comma 0.4 comma 0.6 comma 0.8 comma 1 comma. This is VL, very large or large, medium, high, low, very low, sorry, not large, and very high. So very low, low, medium, high, and very high. These are the buckets that we are putting for the size. And we are going to create a pivot table for size underscore buckets and content rating with values set to rating column. I'm going to write on input dot head, open and close bracket, pd dot pivot underscore table, data is equals to input one, comma index is equals to content rating, comma columns is equals to size underscore bucket, comma values is equals to ratings or rating, not ratings, it should be rating. Content rating spelling is wrong. Content rating. Now I need to change the aggregation to median. I'll write on pd dot pivot underscore table Data is equals to input 1, comma index is equals to content rating. Okay, instead of this, I can copy this and simply add uh, uh, your np.median, right? That will be very easy. So only thing is the estimator or the aggregate function that we want for your pivot table should be median value, right? And then we are going to change the aggregation to 20th percentile or quantile just by using this thing. You can change aggregate function to uh, by using lambda function, just quartile like np dot quantile. I want to make aggregate function has to be 20th percent. So you can do that, right? Now just store the separate value variable for this. What is this? Zero point 0.2 x quantile missing one positional argument. Okay, should be only one. Should be this. Yeah. Now let us um, add a variable to this called as res, right? And how do we plot the heat map is we'll write down sns dot heat map res and pld dot show. So the simple heat map will not give you the values. Simple heat map will not give you the value, the numbers, right? Here also you'll not get the number. So to get the number, what you should do is you should write an annotation is equals to true. You write an annote is equals to true, right? And if you want color of that heat map as to be green color, we'll apply customization C map, color map is greens. So the variable, the parameter is greens. S comma should be there. This will be green, right? So that is what we have. Now I think only stack bar chart is remaining that we can see uh, in the next session. But to just give you, to just introduce that particular topic of your stack bar chart, I'll just add a theoretical point and we can just see how do we plot the stacked bar chart. So creating a pivot table for content rating and updated month with the values set to installs, creating pivot table for content rating and updated month with the values set to installs. So I'm going to write down pd dot pivot table data is equals to input 1, values is equals to installs, comma index is equals to updated month, comma columns is equals to content, right, comma aggregate function is equals to sum. So sum updated underscore month. Don't we have that? We have not created that, right? Uh, Updated month is, it should be created in our data frame, that is input one is equals to, or input one, we are interested to create a new column that is updated underscore month. And in that, we are going to write on pd dot to underscore date time. Input one is last updated and dot dt dot month. So in your data frame, last updated, sorry, it should be updated because in our data frame we have updated column. And if you just check our data frame by using input one dot head, you are going to get a data. You're interested to create a column which will be updated month. So Jan is 1, August is 8, June is 6, June is 6, right? So updated month is we want a number, right? So that's why we wanted to convert categorical variable that is Jan, August, month, June into a number. That's why we have used that. And we are finding the aggregated function of sum. So sum of content rating for everyone for the month of Jan is this, right? Now, let us plot the, uh, let us store this in monthly column, right? Let us store this in variable called monthly. And then you are going to plot the stack bar chart by using monthly dot plot child is equals to bar, comma, stacked is equals to true, comma, figure size is equals to 10, comma 6, comma, plt dot show. This is your stack bar chart. Simple. Figure size is you're setting figure size as 10, comma 6. 10 represents the length, 6 represents the height. So you can change. Suppose you want length as 8. So it will be smaller as compared to that, right? So depending upon the figure size, you are free to add whatever you want to add, right? And there's only small part is remaining, but we'll stop here for the day. Only small part is just an introduction about your Plotly library. Although that is not in our syllabus, but we can discuss that. So that will do it in the next session. If you want to read about that, you can read this Plotly by using this link, this, right? That is also one of the useful library that we have, which we use to plot different graphs. Now this summarizes your entire case study for this particular part. We can stop here for the day. I'll just quickly upload this on your drive and we can stop. If you have any questions, if you want to discuss anything, we can still extend our session by 5 minutes. You are free to ask. Yes. Do you have any questions
Yeah,
here?
yes, Vipul. Regarding the chart and plot and everything, can we add any kind of tooltip or any highlighting when we mouse over thing, or it's just a static layer display?
Yeah, tooltip is available on your Plotly.
Okay,
So
okay.
Plotly will give you
Because
leverage of.
yesterday when you show an example of the heat map, when you mouse over the thing, it's actually display the details.
Yeah, that is something that they have done by
Okay,
using
okay. Different
coding.
live, different programming language using the concept, something like
Right,
that.
right, right.
Okay, 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 okay. Okay,
Because
Vipin. Hmm.
their end-to-end product is to take a data and visualize it, right?
Hmm.
The business is that. So they
Okay,
are more
okay, okay, okay.
interested to
Hmm.
add visualization to this, but it is not required.
Okay, 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 okay.
This is by
Hmm.
using different languages.
Okay, okay. Not using Python. Okay, okay.
But I think Plotly is it gives you the more lively effect. If you just see,
Hmm.
um, just a minute. We'll quickly import Plotly over here. So it provides you to uh, like you can have a screenshot of that particular graph, or if
Okay,
you just hover your mouse, it gives
hmm.
you value. So
Okay,
for an
okay, okay.
example, let's say you want to have a bar chart, right? So let us take a bar chart and let us paste it on. Now can you see this, right?
Yeah. It's that's what asking. Cool.
And you can zoom, you can download this plot as PNG, you can auto scale, produce. See, this is plotly.js. JS means JavaScript, right? Can you see that
Okay.
JS.js?
Yes. So using the JS only, we can able to do some kind of the tooltip and everything.
Yes, because this
Hmm.
library is created over JavaScript, I think,
Okay. That's good.
right? So
Yes.
that's what we have. But to be honest, we don't use this Plotly in the industry because it is not
Hmm.
that user friendly.
Okay,
If
okay,
you,
okay, okay.
but
But in some instance, like a heat map or when we want to differently create any kind of visualization, we can use that one, right? Okay.
yeah, right.
Hmm.
But if you just take, let's say, this is our data visualization library, Matplot
Hmm.
and Seaborn are used 70 to 80% of the time.
Okay.
So it's not widely used. If you just see,
Hmm.
you ask which library is used for data visualization and analysis, not manipulation, sorry, visualization. See, nobody will tell you about Plotly. It comes third, right?
Yes. Seaborn is the Seaborn yeah, Matlock. Mhm.
There are certain other libraries like OK and that other kind of thing, but that is just an advanced part, right? See, first, it is ranking is also first for Matplotlib, right? Then Plotly, then Seaborn, because Seaborn is it is based on Matplotlib, so it is not a separate library. It's just like an integrated version of Matplotlib. And we have ggplot, you have Altair, we have
Hmm.
Bokeh, Pygel, Geoplot,
Hmm. Okay.
right?
Yeah.
But yeah, you can explore this Plotly. It's very
Yes.
sure. All right. I think I should upload this on your drive. That's what I was
Okay.
doing.
Thank you for
Yes, no problem.
thank you.
6. Yes. You already have data set, right? Everyone?
So one you shared morning, right?
Yeah, yeah. Here you'll get a data set, and this is your notebook. So it's in day 17 EDA. Chalo. All right, then everyone revise this, because in this thing we have covered most of the functions for cleaning the columns and data validation part that is widely used. You can implement that sort of logic in a real day-to-day life examples. Like if you are working in the industry, you'll find this. People use lambda functions to manipulate the data, clean the data, uh, and make data validation, right? So it is going to be very helpful for you. You need to be confident in creating lambda function. You are going to use that 1,000 times, 10,000 times in your career, right? So that is something which is very helpful. Chalo. All right, then, everyone. Thank you. Happy learning. Bye.
Thank you.
Thank you, Vipul.